Okay, in our last videos we were looking at permanent magnets, magnets that can't be turned off. This time we're going to look at a better type of magnet that can be turned on and off. We can also control how strong it is. We can also control which end is north and which end is south. The first part of this process involves making a solenoid. A solenoid is just an empty tube made of paper or plastic with insulated wire wrapped around it. Since we want to put electricity, an electric current through the wire, we have to strip the ends to bare metal. I've already stripped these ends so that they are bare metal. The device I've now made is called a solenoid. When electricity passes through it, it is a very, very weak magnet. We can make it into an even better magnet if we put in something made of iron in the centre. I'm using an iron nail. Please note that no electricity will pass through the iron nail itself. If you think about it, that would be impossible. The electricity is going to be confined inside the insulated wires. The electricity cannot get to the iron nail. At the moment, this device is not a magnet. It does not have any magnetic properties. It can't lift these pieces of iron. That's because the current isn't turned on yet. I'm about to turn the current on. You can see from my current supply, I'm using this DC power supply. So one end is plus and the other end is minus. I'm going to turn the power on now and attempt to lift up these two nuts. As you can see, I've now produced a magnet. If I turn the electricity supply off, then the nuts will no longer hold. So I have a magnet that I can turn on and off. This type of magnet is called an electromagnet. Like any magnet, it has a north and south pole. I can try to find out which end is which using the compass needles just like before. I'm about to turn the power on. Let's see what the compass needles do. Okay, you can see that this compass needle is pointing this way. That means that this end of my electromagnet must be a north pole. This compass needle is pointing towards this end, so this must be a south pole. So I have made an electromagnet, a magnet that's only turned on if electricity flows through it. I can also change the direction of the north and south poles if I change the current direction. I want you to watch what happens to the arrows on the compass needle, which are both pointing this way at the minute, if I change the current direction. I'm going to swap the current around and make it flow in the opposite direction. I will do this by swapping over north and south. Notice how the compass needles have now changed direction. This is now a south pole and this is now a north pole. So you can control which end of an electromagnet is north and south by changing the current direction. Thank you.